As we gain enough knowledge related to writing queries, let us explore some advanced DML operations. We can insert query results into a table using insert with select. As long as columns specified for table in insert statement and columns projected in select clause match, it works. We can also use query results for update as well as delete. Let me load the SQL magic and then let me create this environment variable. The environment variable is created successfully. Now we are going to create customer order metrics table to demonstrate advanced DML operations. We will also add primary key to this table. We will be storing number of orders placed and revenue generated for each customer in a given month. I am dropping the table if it already exists. This will take care of creating the table with 4 columns: customer ID, order month, count and revenue. This will take care of creating primary key on the table. Here is the query to get monthly customer order metrics. First we will be inserting customer ID, order month and order count into the table. If the below query is run multiple times, every time data in both orders and order items need to be processed. As the data volumes grow, the query uses considerable amount of resources. It will be better if we can pre-aggregate the data. We will see how to take care of it as we proceed further. Even if you do not follow completely, that is fine. This is primarily to demonstrate how we can actually insert the query results into a table, also how to update as well as delete. Let me run this query. We are joining orders and order items on order ID, and then we are actually grouping by customer ID as well as month, and then we are getting monthly revenue as well as monthly count for each customer. You can see the results here. In 2013 July, the customer ID 4257 have placed 10 orders and the revenue generated is $2,059.75. Like that you can see 9 other records. Here are the number of records that need to be processed every time. Also, it involves expensive join. Typically, when we join tables like orders and order items, which are transactional tables, if you think about large e-commerce platforms, there will be millions of records, and joining millions of records as part of the query will be quite expensive. In this case, we are going to process 172,198 records every time we run these kinds of queries. So we should be able to fine tune that by pre-processing and inserting into tables like customer order metrics. Let us see how we can take care of that. When it comes to this insert, let us first insert the data into the table without revenue. So we'll not be populating revenue. We'll be only populating count. We'll update the revenue later as an example for updating using query results. This is the insert statement. You can see the insert statement. We are joining orders and order items, grouping by customer ID and date. And then we are actually getting the count for each date for each month. Actually, this is month, not the date. We are extracting the month and we are grouping by month. Now let's run this and you can see that 48,059 rows are inserted. So we have to only process 48,059 records going forward, not 172,198 records. And also using this table, we need not join with any other table to get the some of the customer order metrics. Typically, as part of these tables, we will also have all the important attributes of customers or dimensions of customers, not just ID. For this simple example, I'm just populating ID from customers. However, in actual use cases, we might have city, state, many other attributes, not just customer ID. That being said, now let's run this query to validate the data in this customer order metrics monthly. You can see the details here. We have customer ID, month, count and revenue. Now if you scroll down further, we are going to see how to update revenue along with count. And this is expensive operation, but will be running only once. Once it is run, we don't have to run multiple times. We just have to query for our reports. And if you use this pre-aggregated table for your reports and if you run multiple times, the performance of those queries will be much better than the performance of the queries which we have seen earlier, where we are trying to get the metrics from the original tables, orders and order items. And that being said, even this update is not very common when it comes to actual data processing. We prefer inserts over updates. Inserts will be typically faster than updates. Updates are very expensive, especially in this format. So you can see the syntax of update when we want to update several columns using query results. It's not straightforward as insert. You have to say update table name, then alias for the table. We might have to use it as part of the query here. This is also an example for nested subquery. And then you can say set. These are the two fields which we are trying to populate, and these two fields are specified in circular brackets equal to. In circular brackets we have the query. This will actually tell us what values has to be updated for the records. And then we also typically have this where condition to ensure that whatever data we want to update is only updated, not everything. So in this case, we are trying to update only records related to month 2013 August. That's why we have this additional condition also. So this is how the update query will look like when we try to update the query results into a table. Now we should be able to run this. and you can see that it is taking quite a bit of time even though we have very small tables. It took almost 25 to 30 seconds to run this simple query with a smaller dataset. As the data volumes grow, this update might be very expensive. There are ways to fine tune it, but at this time I just want to show how we can actually update a few columns in a table using the query results. As long as you understand the syntax and how to use it, we are good to go. As data is pre-processed and loaded into the table, queries similar to below ones against customer order metrics monthly will run much faster compared to the queries against the original tables. We need to process lesser amount of data without expensive join, and hence the queries will run much faster. We do not have enough data to actually compare the queries against the pre-processed tables versus the original tables. However, it is just common sense to understand the difference. If you want, we can actually simulate and compare the performance, but that is not required at this time, and it is also not in the scope of this topic. You can see the results as expected here. As an example for delete using query, we will delete all the dormant customers from customers table. Dormant customers are those customers who never placed any order. For this, we will create backup customers table as I do not want to play with customers. So I am trying to drop the customers backup if it already exists. Then I'm creating this table, customers underscore backup, selecting from customers. You can see that 12,435 rows are inserted into this table. Now by using left outer join, we should be able to get all the dormant customers. If there is no corresponding record in orders table, that means the customer have not placed any order in his lifetime. We can actually run this and we can actually get the count. There are 30 such customers. We just want to delete those customers. You can also get the number of customers who never placed orders using not exists approach. And this one is with a join, this one is with a not exists. This will also return 30 records. You can see the output here. When it comes to delete, we need to use nested subqueries as part of the delete with not exists or not in. We'll be demonstrating those two below. We cannot use direct joins as part of the delete. The join approach will work with select in place of not exists or not in. However, with delete, we cannot join like this. We have to use not exists or not in with nested subqueries. This is how the query will look like. If you want to delete using not exists, you just have to say delete from the target table from which you want to delete the data. You can give a alias for it. Then you can say where not exists. As part of the circular brackets, select one from orders. This is the most important one. So whatever matches this criteria, negation to it will be deleted, which means those customers who never placed orders will be deleted, which means the records which are in customers underscore backup but not in orders will be deleted. We can run this and it will return 30 rows affected. All the 30 rows are deleted. If you want, you can run the select count against customers underscore backup once again. Let me actually create a cell here and let me take care of getting the count. So I can say select count of 1 from customers underscore backup. Here I have to say count of 1. Now you can see that we got 12,405 records. However, when we actually created the table, 12,435 records are inserted into the table. We have used ctask to create the table. So this is how you can delete using not exists. If you want to delete using not in, you can delete with this approach. If you want, what you can do, you can drop the table once again by going back here, run this query to create the table yet again, and then you can scroll down and you can see the example with not in. Everything is same. We don't need to use nested subquery. If you want to use not in place of not exists, you can directly say select order customer ID from orders. It will give us all the order customer IDs from orders. However, we are only checking for those customers in customers underscore backup which are not part of orders. However, this query is a bit expensive. Compared to this, even with not in, we can leverage nested subquery and the performance will be better. Then you can say where not exists. As part of the circular brackets, select one from orders. This is the most important one. So whatever matches this criteria, negation to it will be deleted, which means those customers who never placed orders will be deleted, which means the records which are in customers underscore backup but not in orders will be deleted. We can run this and it will return 30 rows affected. All the 30 rows are deleted. If you want, you can run the select count against customers underscore backup once again. Let me actually create a cell here and let me take care of getting the count. So I can say select count of 1 from customers underscore backup. Here I have to say count of 1. Now you can see that we got 12,405 records. However, when we actually created the table, 12,435 records are inserted into the table. We have used CTAS to create the table. So this is how you can delete using not exist. If you want to delete using not in, you can delete with this approach. If you want, what you can do, you can drop the table once again by going back here, run this query to create the table yet again, and then you can scroll down and you can see the example with not in. Everything is same. We don't need to use nested subquery. If you want to use not in place of not exist, you can directly say select order customer ID from orders. It will give us all the order customer IDs from orders. However, we are only checking for those customers in customers underscore backup which are not part of orders. However, this query is a bit expensive. Compared to this, even with not in, we can leverage nested subquery and the performance will be better. So wherever you have to delete data like this is the preferred approach over this. Even if you use not in, you can actually develop the logic in similar fashion and the performance will be a lot better compared to this approach. This approach is not very effective because it will actually collect all the order IDs into memory and then it has to be deleted from the main table customers underscore backup from which we want to delete. It uses different way execution.